Hello and welcome to this lecture on the topic of face perception. So I want to start by saying that there seems to be something very special about the way that we process faces. So there's something different that we do when we look at a face and recognize it as opposed to when we look at an object and identify or recognize objects. And we're going to consider today three ways in which face processing is unique or has a kind of special property to it. One of these is going to be looking at the fact that we tend to process the entirety of faces, or the entire configuration and information seems to be very important for us being able to identify and recognize faces in a way that we don't necessarily have with objects. We're also going to consider the fact that we have unique regions of the brain, most notably a region called the fusiform face area, that seems dedicated for processing and recognizing faces. And finally, we're going to look at some individual differences in our ability to recognize faces. So we're going to see there's a kind of continuum of some people are very poor at face recognition. Some people are entirely incapable of face recognition. So we'll look at some patients with prosopagnosia, and then this ranges all the way up to we have some individuals who are classified as being super recognizers that have this extraordinary ability to memorize and identify people that they may have only very briefly seen in the past. So is there something special about face processing? Does face recognition involve different processes from object recognition? I'm going to put the case forward that yes, there are very important differences here. And to start off seeing some of these important differences, so how face processing might differ from object processing or object recognition, let's begin with what is a kind of classic seminal study by Tanaka and Farah. I'm going to talk you through one study that was in their paper that they published, and in this study it consists of an initial learning or study phase and then a test phase. Now in the study phase, participants are tasked with learning the names that correspond to either faces or the house. So in this case we're shown an image of Larry and you're told this is Larry, and then you're shown Larry's house and you're told that this is Larry's house. Now you'd see a range of different faces and houses, and your job basically is just to memorize these as well as you possibly can, knowing that you are going to be tested later and you've got to recall and say, yeah, that's Larry, no, it's not Larry. Now in the test phase, the experimenters then had two conditions whereby they varied whether participants were given either the entire whole face that they'd seen before or a part of the face, and similarly they were shown the whole house or a part of the house. So if you look at the examples that are on here, you might see in the part condition just Larry's nose, and you've got to say, is this Larry's nose? Or in the whole condition you get his entire face. In the part condition for the houses, you're just shown the doorway and you've got to answer, is this Larry's door? Or you get presented the entire house that you've looked at before. Now if it's the case that we process houses or objects, in this case houses, and faces in fundamentally the same way, what would you expect to observe if you ran this experiment? How would you expect the performance to differ across these two conditions? I think most people would intuitively expect that the accuracy is going to be worse when you're doing the part as opposed to the whole object condition. It's just a much tougher thing recognizing whether it's somebody's nose or their door, as opposed to being given the whole information that you might have learned before. Now if it's the case that we process faces and houses in fundamentally the same way, then there shouldn't be any difference in our accuracy rate for how we perform in the part and the whole object conditions. So in other words, you would expect us to be in the isolated part condition, our recognition for the faces and the houses would be sort of equally as bad, and then in the whole condition we'd expect a little bit of an improvement, but we would expect that improvement to be similar for both the face and the house condition. But that isn't what happens here. So if we look at the figure A on the top right of the image here, we have along the y-axis is the percentage of responses that they got correct. And then on the left-hand side, we've got the responses for faces. And the most notable thing that stands out here is that there is a big difference between performance on the isolated part, so when you're given just a nose, versus performance on the whole object condition. So our accuracy is much, much better when you're provided with the entire face, whereas it's much, much poorer when you've only got one feature, such as the nose, to focus on. Whereas in contrast, when we're trying to recognize or identify the objects, the houses, performance is equivalent. It doesn't seem to matter whether you're given the entire house or you're given this single feature of the door. I mean, in fact, there's a little slight, very small, non-significant performance improvement in the isolated part condition. There's no good explanation for why that would be the case in this experiment. It's just what seems to have happened. So this was the first, or one of the first studies that kind of really sheds light on the fact that there must be different processes going on, and this configural entire information about the face is important for recognition ability. Another sort of illustration of where you might see this effect could come from our ability to recognize famous people from either individual features or the whole information. So if you try this example, I'm just going to reveal individual features of a celebrity. So we'll do this step by step and see if you can recognize who this individual is. Now this individual actually has some very distinctive features, so you might be able to pick out who it is. Now for most of you, you may have picked up who that is, but you probably still find this relatively challenging. Now if I present the entire face, what you had there before when we had all of those different individual features is essentially the same information as what I'm providing you right now, but what you don't have is the configural information, so it's not structured together. And now when you look at this image, it should immediately pop out to most people that, yeah, this is obviously George Clooney. So that's one example again of this configural information, and everything put together makes it much easier for us to do accurate face recognition. You can also get a sense for how the brain processes faces holistically in something known as the composite face illusion. So here, all I want you to do is look at the faces on the screen and focus on the top halves only. And I want you to think to yourself whether all of the faces that are appearing here are the same, or whether any of these faces differ from each other. So look at the top halves of the faces in row A. Are they all the same? Yes or no? Now let's look at the faces in the second row that I present here. So again, just focus on the top half of the faces and tell me, do you think that they look like they all come from the same face? Now the trick here, if you haven't noticed it already, is that the top halves of the faces in both of these rows were identical. However, when we end up aligning them with distinct bottom halves, so in that top row that I showed you, they ended up being paired with bottom halves of the faces that differed. Whereas in the bottom row, all of the faces on the bottom section were identical. Yet to many people in this top row, you perceive that top half as being slightly different from each other. So you perceive that there are differences in that. And this occurs because faces are perceived as this integrated whole. So even though I've asked you just to focus on the top half of the face, we're processing both the top and the bottom bits together. This is just a simple kind of strong innate tendency for us to do this. Now when the top halves of the face are aligned with the bottom parts, which you can see in the bottom row here, it's much more obvious that these top halves are coming from the same person. And the thing that's crucial here is that this same sort of composite illusion doesn't occur if we do it with non-faces. So if I gave you another example with objects and we put on a mixture of different things on the top and the bottom half, you wouldn't be liable to fall for this sort of illusion. So it's indicating that there is something unique about the way that we're automatically processing the entire face when we look at it, and it really influences our perception of the face. So some additional insight into the fact that when you look at a face, you end up processing everything together and including the configural information, rather than processing individual parts separately. So it's not the case that we go around and process the nose, then the eyes, then the mouth, etc. It's the entire configuration that seems to be important. And some insight into the fact that this occurs comes from the way that we process inverted faces. So in other words, when a face is flipped upside down. Now, before we look at one of these examples, how good do you think you are at face perception when faces are flipped upside down? Do you think you are equally as good, almost as good, but a little bit slower, or pretty terrible? So have a think where you'd rate yourself on those three items. Now, let's have a look at the following face and see if you can recognize who the person is here. Now, many of you, if you're looking at that, it might come to mind that this is Adele, that you have a kind of recognition there. If not, that's not a problem. It is more challenging to recognize a face upside down. However, what is more striking about this is if we now rotate that image that I've shown you through 180 degrees, and what should now rather automatically pop out is this fact that the eyes have been flipped around. So they've been photoshopped to be the wrong way up, but we just don't tend to notice that on the inverted face, whereas it's popping out as an incredibly easy feature to detect right now. Again, let's look at one more example. So see if you can spot any features that are unusual on the face here. And if we flip this upside down, it's a shockingly kind of grotesque mouth that is the wrong way up. Now, this original stimuli that was used for this was an image of Margaret Thatcher, as an ex-British Prime Minister, which if you've watched The Crown, you'd see a brilliant Gillian Anderson version of her. And in this Thatcher illusion, the eyes and the mouth are again inverted on here, but it's very difficult to detect that or notice it. So why does this happen, and what is it really illustrating here? Well, firstly, at one level, we only seem to be expert at recognizing upright faces only. So if we think about where we end up storing structural models of representations of what a face looks like, when we're storing these in the brain, we only tend to store an upright version of them. So it's very difficult for us to then recognize or identify faces that are the wrong way round. What we typically do is then kind of mentally rotate that image in order to be able to recognize who the person is. And it also suggests that there's probably two sorts of processing that occur when we're trying to recognize a face. The first one that is fundamental and seems to be really important is this configural holistic processing. So we look at the arrangement of the different features on the face and compare this to a stored mental map that we have of faces. Now, again, as I've just mentioned, the problem is when it's upside down, we don't have a store of mental maps that we can compare this with. We don't have known mental representations. But we then engage in a second set of processing where you might look at the individual features and the parts. Now, when we're looking at the face inverted, if you look at them each individually, they tend to look okay on their own. So you look at the eyes, yeah, they look okay. You look at the mouth and it looks fine. So when you're looking at it individually, it's really hard to detect that it is being inverted or flipped the inappropriate way. Okay, just to illustrate the point I made previously that we are essentially specialized for recognizing faces in the upright orientation, I've given you a face that's shown from a frontal view. So if you look at the top right hand side, look at that person's face, and then see if you can work out which of these three images to the left hand side, which of these three faces are the same, come from the same person as you see in the top right hand side. And most people, when you're trying to do this task and work out, it's really challenging. What you might end up doing is looking at the faces on the left hand side, looking at individual features. So you might look at the nose, and then you come back to the person on the right and compare, is that the same one? Is the chin the same? But it doesn't pop out to us. We don't automatically know and recognize who the person is. Whereas if I give you the image of the person from the upright view, you look at him on the left hand side and then you try and identify who it is, it should pretty automatically. I mean, it's not that easy, but it should come out to you that the person on the far right is the one that matches the person from the frontal view there. So a nice demonstration there that we do find this incredibly challenging to recognize people in a non-upright perspective. So if we are making this argument that there is something unique about face processing, that maybe there's a specialized region of the brain or specialized processes dedicated to processing faces, then what you might expect to see is patients that report face-specific deficits. So they may have had damage to this specific region that's engaged in face processing. Damage to this is going to mean that they can process objects, but they're impaired with face processing. And we find this. We find relatively common disorder known as prosopagnosia, which translates as kind of face and without knowledge. So prosop for face, agnosia is lacking knowledge. Face-specific deficits are found in patients with face blindness or prosopagnosia, and these patients generally have a very severe impairment in face recognition and no notable impairments in object recognition. Importantly, it's not a naming deficit, so it's not the case that they can process and identify the faces but just can't search for the individual's name. It seems to be more to do with the kind of perceptual process in identifying the patterns and the configural features of the face. You do find with prosopagnosia that a lot of people tend to get by through using other cues, so whether that's someone's hair color or the clothing that they're wearing. It might be cues to do with the way that they walk in order to recognize them. But generally this can be quite a sort of socially debilitating disorder to have. I mean, if you imagine you now being unable to recognize people's faces, it'd be very difficult in a busy room to effectively navigate and interact with other people. So let's listen to a short interview with Oliver Sacks, who's passed away recently, but he was a very famous neurologist who wrote some brilliant books. And he was also a patient that suffered from prosopagnosia.
Being social beings, we need to recognize each other, and we do so in all sorts of ways, by the way people move, the way they dress, their voices, where they are, but in particular we are very good at recognizing each other's faces. Well, when I say we, I mean the majority of people. There are some people who are not so good at recognizing faces, and in extreme cases people may not recognize their husband, their wife, their children, their oldest friends, and they are called face blind. They may see a face perfectly clearly, but it doesn't convey identity to them. And the technical term prosopagnosia. Prosopon is the Greek for a face, and an agnosia is not recognizing. So the term prosopagnosia was introduced in 1944. Although one talks about face blind as if the face blind are a species apart from the face normal people, in fact there's a whole population, really a continuous population, with the 80% of the people in the middle, and the poor recognizers at one end, and the super recognizers at the other. The super recognizers are people who have indelible memories of faces, who will say, yeah, I remember you. You served us in that cafe in Naples 27 years ago. I think my mother was probably bad at recognizing faces. She was very shy. She was ill at ease with large numbers of people. My father was the opposite. My father was a sort of super recognizer. I think he recognized thousands of people, and he was highly sociable. Now, whether his sociability made him good at recognizing faces or vice versa, and whether my mother's shyness, whether that was a cause or effect, I don't know. I think with myself I have both. I'm somewhat diffident in social intercourse, but it's also made more difficult because I often don't know whom I'm talking to. I published my book, The Man Who Mistook His Wife for a Hat, and Dr. P, whom I described, had overwhelming problems with agnosia of many sorts. He didn't recognize people. Although interestingly, he recognized cartoons, because in a cartoon there is an exaggerated nose or an umbrella. There are particular marks by which one can recognize a cartoon. Churchill has a cigar, Schnozzle-Durante has a nose, Einstein has his moustache and those big sad eyes, but he couldn't recognize faces, even his wife, even himself, in the normal way, and he also had difficulty recognizing objects. He couldn't recognize a glove. Now, after my hat book came out, I got dozens of letters. People were interested and moved by various cases, and in particular, I got some letters in which people wrote of their own difficulty recognizing faces and places. They said they were not as, unlike Dr. P, who had only developed the difficulty with a brain condition when he was in his 60s, the people who wrote to me said that their condition had been lifelong, and often other people in the family had had it. And this gave me the impression that out there might be scores, hundreds, thousands of people with difficulty in face recognition who didn't think of it as a condition, who had never consulted a neurologist, but who were outing themselves, who were coming out now they had read about Dr. P. And so I was intrigued by this apparently overlooked but not small community of people in the world who might have problems like my own and perhaps much worse.
We can also see there's been some famous case studies of prosopagnosic patients that are reported in the literature. So, for example, Edward, as reported by Brad Duchesne, is a kind of classic example of a prosopagnosic patient with severe deficits for faces, but intact processing of non-face objects. You've got Mr. W, was a prosopagnosic farmer, really struggled with recognizing human faces, but if you look at the herd of cows that he owned, he was able to distinguish between particular cows. So you probably then rely on the different patterns on the skin of the cows. Similarly, another farmer, WJ, prosopagnosic for human faces, but was able to distinguish between different sheep. And then patient RM, prosopagnosic toy car expert, real difficulty processing faces, but could distinguish between the 5,000 plus different cars that he owned. So again, you're doing fine-grained object distinction with impaired face recognition ability. Let's look at one more case study that I really think illustrates some of the frustration or the difficulty that would be experienced by patients with prosopagnosia.
Your mouth is getting tired.
Meet Terry Sweeney, a professional photographer. She was a firefighter.
Your mouth is getting tired.
Meet Terry Sweeney, a professional photographer. She was a firefighter until an injury damaged part of her social brain, the circuitry she uses to recognize faces. The disorder is called prosopagnosia. For example, the person Terry has been photographing here is her mother. Now, because of her injury, Terry can't recognize any face.
Make me smile.
Not even her own mother's.
I'm really grateful you don't drink a lot of coffee.
In this test, Terry takes a Polaroid picture of her mother.
Terry, you just took a picture of your mother. And I want you to take a look at these and see if any of them are the picture you took or not. They may or
Now, Massachusetts General Hospital researcher Dr. Nancy Etkoff shows Terry several Polaroids with only faces showing and asks Terry to pick out her mother.
You know.
Okay, if you had to guess, which looks to you the most like your mother? Just looking now, you can't tell which one of these. None of these really look like your mother to you.
No.
Okay.
If you just cover up the face and I just look at the clothes, I can tell you.
Okay, do you want me to uncover them? Okay, why don't I do that? I'll uncover them so you can see what they're wearing and other parts of the picture.
And see, that's her, because the pink and purple shirt.
The shirt. You recognize the shirt.
It's the hardest, I think, with my family, not to be able to personalize them with a face or a sense of timing. You know, it's kind of like I've lost everybody, like everyone's gone, and all that I'm really left with are facts without faces, you know?
When Terry looks at these slides of famous faces, she can't recognize them, although other cues like hairstyle prompt a guess.
Is that Madonna? Because her hair, look at her hair.
It's Marilyn Monroe.
Oh, really? I always feel like I'm struggling and always feel like I'm fumbling through myself to find a connection, to find a bridge that'll just pull everybody right back all of a sudden.
Can you tell who that is?
No.
Okay, I said Bruce Springsteen.
That's not Bruce Springsteen, is it?
Why do you say that?
This guy's ugly.
Now take a look at that woman right there. Does she look at all familiar to you?
No.
Not at all. What if I say that's you?
I bet not be me.
It is.
Really?
So that was a somewhat sad ending to the video, but I hope it gives you some insight into the everyday challenges of living with prosopagnosia. Now, what can prosopagnosia tell us about the systems involved in face recognition? Now, on the one hand, if we've got these dozens of patients that are turning up where they report specific deficits in face recognition, does this indicate, or can we infer from this, that there's likely to be a region in the brain that is specialized just for face processing, and it's this region that has to be damaged in these patients? And it's really tempting to see this evidence and conclude this. But from this evidence alone, it doesn't allow us to come to that conclusion. We can't really definitively say that face processing is something that is distinct from object recognition. So for example, it could be the case that these patients have damage to a much more general object recognition system or processing unit, and we then see the impairment with faces because face processing just represents a very difficult or the most complex form of object recognition. So in other words, you've got damage to this general object recognition system, and the damage isn't severe enough that it knocks out object recognition, but it knocks out the more challenging versions of object recognition, i.e. Processing faces. So just to illustrate that, you might think that on the left-hand side that these prosopagnosia patients are demonstrating the knockout of a face region as opposed to an object region, or it's the case that we're looking at patients that have damage to this general object recognition system, and the impairment that leads to is just the higher end complex object processing. So when scientists want to distinguish that a specific region is responsible for face recognition, the strongest evidence that you could find in support of this would come from locating patients that have the opposite syndrome. So where they would have impaired object recognition and intact face recognition. So if you could find a patient where this was the case, this would be pretty convincing evidence against that image on the right hand side. So against the idea that object and face recognition are the same and just face processing is a more complex version. So this would rule out the possibility there's a sort of generic difficulty. And this is the power of something known as a double dissociation. And remarkably, we have evidence of exactly this form of dissociation. So patient CK, that's reported by Moskovich. So if you take a look at the figure here, you've got a still life that's produced by the very quirky 16th century Italian painter Giuseppe Arcimboldo. And this shows a bowl of vegetables. Now, he demonstrated severe object agnosia, so an inability to perceive objects, but had intact face recognition. So when you showed him the image upright here of the bowl of vegetables, he would have a very hard time distinguishing A, that it was a collection of vegetables, and B, distinguishing individual vegetables in there, that you've got like an onion, radish, parsnips, etc. But the interesting thing is when you then rotate this image around, it turns out that it's in the sort of form, or it contains the features of a face, and he would accurately interpret that what I'm looking at now is a face, is the image of a face. So there's a clear dissociation that's going on here of the face and object recognition systems. There's also some interesting evidence of the fact that he was very poor at processing inverted faces. So even worse than you and I would be. Inverted faces, so when they're upside down, are obviously challenging, whereas we find it slightly difficult. He would find it nearly impossible. And another indicator of the reason why that was so difficult for him is that when faces are upside down, we typically use our object recognition processes or mechanisms to look at the face. We're not using our face processing systems. So if this is a patient with damage specifically to the object recognition system, it would make sense that he is a bit more severely impaired at inverted faces. Which brain regions are responsible for face processing? And it turns out that there's converging evidence that the fusiform face area, which is a region you can see located in the top right here in the rotating brain, this highlighted region in red. So you've got evidence that comes from four different viewpoints, or four different sources. So firstly, if we look at where lesions or where reduced activity is associated with patients with prosopagnosia, they'll show reduced activity or damage to this fusiform face area. So that's evidence one. We also have evidence from single cell recording in primates that if you sample cells in the superior temporal sulcus, so this is a region that overlaps with where the fusiform face area would be in humans, you get cells that seem to be selectively tuned or tend to respond to the presentation of faces as opposed to any other stimuli. So on here we've got the illustration of two cells in superior temporal sulcus that respond to these different forms of stimuli. So A, B, C, D, E are primate and then one human face being presented. These other stimuli are abstract objects and a bit of clothing. And for this cell, you get strong responding for A, and then smaller for B and C, and definitely responding for D and E. And then similarly, another cell, much stronger responding for the faces in A2E as opposed to the other stimuli. We also get evidence that the fusiform face area is more strongly activated for faces as opposed to other stimulus category. So using fMRI, you can present images of faces and objects and then do a method of subtraction to compare what is the level of activity when you look at a face as opposed to when you're viewing an object. Now, from a methodological stance, this method of subtraction is quite important. So if you just to show people images of a face and see which regions of the brain are activated, you're going to get loads of different regions that are responding. So you will have pure visual areas that are responding. So V1 will respond to the visual input. But if you really want to pin down what are the regions that are specifically responsible for faces, what you would want to compare is what regions light up for a face versus what regions light up and are activated for something that involves the same sort of categorization, it's got visual input, but just doesn't have the face. And in this case, it could be stimuli such as a crab, a cell phone, and whatever this thing is. It looks like a bit of maze. I don't know. I'm not entirely sure. You can interpret that. So you then want to look, what is the difference? What regions are just activated for the face as opposed to this? And again, you get this strong activation here in the fusiform face area. Finally, if we want to create a virtual lesion, when you put TMS applied to the face area, this again impairs face recognition ability. Now there's several theories of face recognition that have been put forward, but one of the most influential, that I've put just a very simplified version of here, was proposed by Vicky Bruce and Andrew Young in the 1980s. And the key point here is that it's a cognitive model of the different stages that are involved in processing and recognizing a face. So we begin with very basic level face detection. So we decide whether the stimulus that we're looking at is a face or not. And this is something that, again, occurs very early on in visual processing and automatically. So we're not consciously thinking about what we're looking at is a face or not. We then engage in some form of structural encoding. So we do this holistic processing of the configuration of the combined features of the face. And this is when we process along two separate pathways. So there's one pathway that matches this structural map that you've constructed to representations that you have stored in long-term memory, and then matching these representations to a particular name that allow you to go, yeah, this person I'm looking at, that's John. We also then, on a separate stream or a separate pathway, process the more variable characteristics of the face, so things that are open to change, such as the way that their speech or the way that their lips are moving as they talk, the current facial expression they have, are they angry, sad, etc. So with the different stages of this process model of face perception, you can observe patients that have deficits at different stages of this. So at one level we can see prosopagnosic patients that have deficits across both areas, where they might be able to detect the presence of a face, but they're unable to recognize it and they're unable to process expressions. At the more severe level, you can have deficits as well, actually being able to identify the presence of a face. We can also find some patients that might have specialized damage to the ability to recognize people from their face. So they might be able to still tell you that this person is happy, they're smiling, etc. But they're not going to be able to put a name to that face or recognize who the person is. Whereas other patients have deficits purely on the kind of assessment of someone's expression. So they recognize, they'll be able to tell you, yeah, that's John, I know him, but couldn't accurately detect what's the current emotional state or expression of John. Okay, look at the image that's on here and tell me how many different people do you see. So good opportunity just to pause the video and see how many distinct faces appear here. So through this demonstration and also through many other empirical research studies, we know that our ability to recognize unfamiliar faces is generally very poor. And this has some important implications. So for example, if you think of people at an immigration desk trying to identify whether somebody's passport photo matches the person that's standing in front of you. It also has important implications for eyewitness testimonies of whether you recognize the person that you claim you saw several weeks previously. Now, if we're looking at people that we're familiar with, our recognition is much better. So if I showed you two friends' photos that you knew well here across very many different domains, you might be pretty good at knowing that there's just two people. But one of the things we find is that there is this continuum of individual differences in our ability of facial recognition. So again, as Oliver Sacks said, many people, maybe 80%, sort of fall within this broad middle where we're pretty good at face recognition, or at least reasonable, and then some fall at the lower end, and at the very lowest, those with prosopagnosia, but we have some at the high end that we classify as being super recognizers. So let's have a look at some of the research and the data on super recognizers.
We see hundreds of different faces each day, but how many would we recognize if we saw them again? I'm not bad when it comes to recognizing faces, but there are people who are much, much better than me. They can spot a face in a crowd for an instant and remember it forever. Scientists call them super recognizers. PC Gary Collins is one of them. His skills were highlighted in 2011. While reviewing CCTV footage from the London riots, he successfully identified 190 people, almost 4 times more than any other officer.
Quite a lot of people I picked out I'd never met before.
Despite only seeing photographs of some of the rioters from police records, Gary rapidly identified them in the CCTV footage. Even with their hoods up, Gary could still recognize them.
I was given this picture. I was able to go back to exactly where I'd seen them in the footage, and bearing in mind there's thousands of people.
Dr. Josh Davis is a psychologist from the University of Greenwich. He has studied Gary and other super recognizers like him. So are people like Gary very rare?
Gary's between 1 or 2% of people seem to have this sort of super recognition ability.
At this point in the filming, Gary and I are asked by the production team to continue our chat in a nearby cafe.
But what they don't know is that I set up a bit of an experiment.
Can I get a coffee here?
Coffee.
5 people who are already set up in the cafe are going to interact with them.
Sorry, do you mind if I just write down the table? Are you Michael Mosley?
I am, hello.
Hello.
Just to show how good Gary is at face recognition, we are going to ask them to try and identify those 5 people.
While you were there, you were taking part in my experiment.
Ah, very sneaky.
And all the people you saw in the cafe are part of that experiment.
Yeah, right.
Yeah.
And what I'm going to ask you to do is try and identify them in a few minutes in a lineup.
I genuinely wasn't expecting that. Josh has asked our 5 people to change what they're wearing. They have now joined 10 other people in the lineup. Will we recognise any of them? I'm absolutely certain this lady.
This lady was in the cafe. Don't recognise this lady.
Yep, you served me a cup of tea.
This gentleman was in the cafe. He asked for the salt.
You look familiar, but I'm not convinced.
Don't recognise this lady.
I think, but I couldn't be absolutely sure. Time for the results.
Michael first, yeah, you got 4 out of 5. And Gary, you also got 4 out of 5.
But something unexpected has happened. During the lineup, Gary also recognised 2 additional people who were in the cafe.
He was in the cafe. I just remember him walking past and back out again. He walked in wearing a blue hooded top and he went into the toilet.
It turns out Gary is absolutely correct. These 2 did come into the cafe, but I hadn't seen them. They were only in there for a matter of seconds, but Gary caught a glimpse and remembered their faces.
Yeah, I just walked into the cafe and walked out again. I was there for literally a couple of seconds and just didn't think anyone would see me.
I just went in to use the toilet. I didn't realise he was watching me.
So Gary had recognised 2 people he had barely seen. I am impressed.
What this shows, which we found in our research, that Gary only needs quite a fleeting glimpse to be able to recognise somebody later.
Scientists discovered the existence of super recognisers in 2009. They are now trying to uncover how it works. They know that there are specific parts of the brain responsible for identifying faces.
This is the fusiform face area. This is part of the general visual system of the brain. These areas seem to be specialised for the processing of faces rather than other objects.
So in someone like Gary, you'd expect them to be more active than, say, in me?
We would expect someone like Gary to process these areas so much more effectively that they would be more activated.
Could I become a super recogniser?
I don't believe so. I think Gary exceeded you, and I think that he was born with that ability.
The advantages of people like Gary to the police are obvious. But it is hoped that this emerging science could also help us understand how face recognition works and how memories are stored and recovered from the brain.
So let's imagine that you're a researcher and you want to understand what somebody's facial recognition ability actually is. So if somebody comes to you and they say, I'm a super recognizer, I never forget a face, how would you actually go about testing this? So researchers can do this in a couple of different ways. One test involves showing people images of celebrities before they were famous and assessing their ability to identify the person. So in this case, if we look at the figure in the top left here, figure 1, these are examples of 4 faces that are similar to those used in the test. See if you can work out who those 4 people are. So these are celebrities taken years or decades before they've become famous, or before we're typically used to seeing their much older face. So if you can't recognise those, they're Malcolm X, Bill Clinton, Scarlett Johansson and John Wayne. Maybe you don't know any of those. Another way that you can assess people's facial recognition is to give them a version of the Cambridge face memory test. So in this figure 2, it's on the right hand side of the screen here, participants would be first of all given a set of training images that you have to remember. So you're given a person's face from front on and then separate angles slightly off of center. And you would then go through a kind of progressively more difficult recognition test where at the easiest level you'd be given the same image that you've tried to learn at the start, so exactly the same images. You would then get the same images that you've learned but slightly novel, different versions. You would then have these novel versions with a little bit of noise, so you've got a kind of lower quality version of the face that you're looking at. You might then uncrop the image. So you would have the same person, but now you've got extra details such as their hair that you haven't seen before. You've got their ears. And then at the hardest level, you would see their face at a profile view. So something that you haven't learned before. And you can gauge someone's performance on this as a score from 0 to 100. And what's plotted on the figure is individuals' performance on the y-axis, the before they were famous test, and along the x-axis, the Cambridge Face Memory Test. And those that are sort of in this top right quadrant are the individuals that we might arbitrarily classify as being super recognizers, that score well above other people. But I think you'd also recognize that there's a nice continuous distribution all the way along that Cambridge Face Memory Test. So it's not that everybody is clustering towards the midpoint or up towards the end. There's this real variability in how good people's facial recognition abilities are. So what are the applications of super recognizers? We've already seen that this can be really useful for police forces. So finding officers that are or have incredibly good facial recognition abilities, it's probably useful to deploy them and use them for watching CCTV footage or attending riots to identify suspects. You could also have them watching live footage at places where there's large gatherings. So again, this is relatively controversial, but if you've got either CCTV footage or live videos of somewhere where lots of people are gathering, if this police officer knows and stores the memory of hundreds or thousands of criminals that they are actively pursuing, they'd be very good at recognizing these people in the crowd.